Okay, so on this day, students are going to distinguish between addition and subtraction story problems. And this is just going back to like all of the work we've done. CGI, model drawing, they're still not strong at this. We've still got to work at it. And one of the pieces of feedback I got, and one of the things that I noticed, is kids are actually pretty good at writing the correct sentence, even if it's like a subtraction sentence where the start is unknown. They'll understand it's subtraction and they'll set it up like this. But then, even when they set the equation like this, they're still ultimately doing 7 minus 5, right? And so just today, our emphasis is really on when we write an equation, stopping and thinking, what part of that equation is missing? Is it the whole, the answer to the big number in the equation, or the small number, the part of the equation? So that's the lens we're bringing today, and really, really exploring that. So we're going to start, we've done a lot of work with modeling and writing equations. Today we're going to focus on addition and subtraction and just distinguishing between those two. So you have them do these two problems, you have them draw the models, you have your discussion, you write your equations, right? The thing to point out is that the words were the same here. Cookies, giving away cookies. The numbers were the same, right? But in the end, this is what this equation looks like. Even the operation we wrote, right? Whereas this is what this one looks like. And these don't get the same answer. And so what does that tell us? When we draw our model and write our equation, there's going to be this extra step of looking at the equation and deciding, am I looking for the part or am I looking for the whole? Am I looking for like the total whole amount, right? Or am I looking for just a piece of that total? Here I'm looking for a part, right? And so I would just subtract 8 minus 3 is 5. Whereas here I'm looking for the whole total. That's because we don't know how many he had to start with. And so I'm not going to subtract, actually. Even though it's a subtraction statement and it seems like a subtraction story, I have to work backwards to find the total. I have to add these up. And so having that conversation. What does that mean for us? From now on, if we see an equation, when we're writing our model, if we think it's addition or subtraction, we're going to use a part-whole chart and fill in our numbers on the part-whole chart to do a little extra stop and think. Because truthfully, our kids do get these ideas, they're just not stopping and thinking. And perhaps adding like a little extra step along the way will bring in that metacognition, right? When I fill this in here, 8 is the whole, and we've got 3 and question mark. Whereas when I fill this in here, question mark is the whole, and I've got 8 and 3, right? Really different. All right, so now we're gonna practice, right? We're gonna choose our operation by deciding whether we're looking for the part of the whole. You're going to put up what you think with your hands, put up a P for part or a W for whole. And so you're letting kids vote, right? You're talking about it just as equations for a little bit, letting them vote, talk, get an answer as a group on your whiteboards. And then there's a story problem to kind of explore that further, and they do some IP. There's no real PowerPoint for lesson 182, and that's because the full day is no talking, it's just working and problem solving and doing this exact lesson again, because that's what our kids need, right? It's just story problems with experience, drawing a model, which I didn't do here, the equation, the part-whole box, writing a complete sentence, right, to really get into the idea that these questions are not the same. How many cookies did Jason have now versus how many did Jason have to start? All of that work to make this like a really rich, we're going to do 5 days of story problems here to like get kids' brains in the right spot before they get to third.